In this one, we've got a ship leaving port, and it sails first for a while at one bearing, and then it turns and sails at a different bearing. So here's the beginning of my picture. I've got the port here. From there, the ship is sailing at a bearing of north 47 degrees east. So here's my due north and my due east. So I'm starting from here and going 47 degrees to the east. Now I don't know how far it's going in this direction, so I need to figure that out. It does give me the speed of the ship, and it tells me how long it sailed at that bearing. I'm going to use this formula to figure out the distance that it went in this direction. That's distance equals rate times time. So I've got my rate is 22 knots, and my time is 3.5 hours, and that's going to give me 77. And since this was in knots, which is nautical miles per hour, technically this is going to be nautical miles. So now we know the distance that we want to make this line segment. Then at that point, the ship turned and sailed on a bearing of south 43 degrees east. So I'm at this point where it turns. So from there, I want to figure the new bearing. I want to draw my due south direction, and it's going 43 degrees to the east from there. So that means that this angle right here is going to be 43 degrees. Again, I want to know how far it went in this direction. I'm going to take my 22 knots times the time of 4 hours. So this time I have 22 times 4, which gives me 88 nautical miles. So this distance right here, I want to make it 88. Now I want to draw in a line that goes from the port to where the ship is now. This distance down here is actually the distance I'm interested in. Let's call this one D. So that's all the way from here to here. It's not the horizontal, but it's this line that's going a little bit below the horizontal. I'm going to redraw this triangle to make it a little bit easier, but before that I can figure out some more angles in some of these triangles. From north to east is a right angle. So this right here is a right angle, and that means that this angle right here would have to be the complement to this one. That would make that one 43 degrees. Over here I can figure out this angle also, because right here I've got from south to east. That would give me a right angle right there, and that means these two angles are complements, which would make this one 47 degrees. Now that doesn't really get me the angles in the bigger triangle that I'm looking for, but it does let me find out one thing, and that's what this angle is up here, this entire angle. So far in this triangle, I've got 43 degrees and 47 degrees. Those two add up to 90 degrees. If I subtract that from 180, I get 90 degrees, and that tells me this angle is a right angle. So I'm going to redraw my triangle so that I don't have this extra stuff in it. Here's my redrawn triangle. All I know is that this is a right triangle, and I've got two of the sides, and I'm trying to find this third side. Since I don't have the other two angles, the easiest thing to do here is just use the Pythagorean theorem. And it happens in this triangle that the length I'm looking for is the hypotenuse, because it's across from the right angle. I would take 77 squared plus 88 squared, and that's going to equal d squared. If I do this on my calculator for this side, I get 13,673. Then I'm going to take the square root of that to get my answer for d. This gives me 116.93, and there's some more digits there. Now I'm going to go back and look at how many significant digits I have. All of the numbers that I have in here are 2 significant digits. So I'm going to round this to 2 significant digits, which means I'm rounding it to the tens place. That would give me 120 for my answer. So the ship is 120 miles or nautical miles from port. One last problem. This is kind of a tough one, so we have to set it up really carefully. Francisco's trying to find the height of a tree. He stands at one point on the ground, and he finds out that the angle of elevation to the top of the tree from there is 36.7 degrees. Now here's my picture. So here's the tree. Here's his first location where he was standing. We don't know how far that was because the problem didn't tell us, but it does tell us that the angle of elevation from there to the top of the tree is 36.7 degrees. And since he's trying to find the height of the tree, I decided to make that h. So here's my h in my picture. And I wanted to set a variable for this distance since I don't know that. So that's d1 is the distance from his first location to the base of the tree. Then what happens is he moves back 50 feet. So this is his second location. And from that point, the angle of elevation to the top of the tree is 22.2 degrees. So we've got a different angle here. Now what we want to do with this is find the height of the tree. This is a little bit misleading because you might think that you can just use the h and the d1 or the h and the 50, but actually you can't do that. 50 isn't the base of this bigger triangle. The base of the bigger triangle would be d1 plus 50. So for our second triangle that we're looking at, that side is actually d1 plus 50. Let's start with this smaller triangle and just write a trig relationship between the angle and the h and the d1. For this angle, the h would be the opposite, the d1 would be the adjacent. That would give us tangent. That tells us that tangent of 36.7 degrees is h over d1. That's all we can do with that triangle for right now. Now let's look at the bigger triangle, which is this entire thing. We can do the same trig relationship for that one. This time we would have tangent of 22.2 degrees. And our opposite side is still h. Our adjacent side is this entire base of the triangle, which is the d1 plus 50. The question is, how do we put these two together so that we can solve it for h? Because that's our end goal, is to find the height of the tree. We do have two variables because we don't know the h or the d1, and we've got two equations, so we should be able to put these two together to solve it. And a lot of times if you're trying to solve two equations with two variables, you can use the substitution method. To do that, you have to have one of the equations solved for one of the two variables. Let's take this first equation, since it's a little bit simpler, and let's solve it for the d1. To solve this for d1, we could cross multiply. That would give us d1 times a tangent of 36.7 degrees equals h. If we're trying to solve it for d1, that means we'd want to divide both sides by the tangent of 36.7. We've got that. Now the idea is that we can substitute this expression into our second equation in place of the d1. That will give us an equation that only has h in it, and then we'll be able to solve that for h. So now we're going to take this equation where we have the d1, we're going to substitute in this expression. And I want to be really careful in doing this substitution, so I'm going to put that expression in parentheses. Now I've got kind of a nasty equation here. I'm going to start out just by simplifying it as easily as I can. And first of all I'm going to do is cross multiply. The tangent of 22.2 degrees times all of this that's on the bottom on one side. On the other side I just have 1 times h. Then I'm going to simplify on this side a little bit by distributing this tangent of 22.2 degrees. Next, I want to get all my h terms on the same side. I'm going to take this entire term and move it to the other side by subtracting. Now this is getting really messy, so I'm going to go ahead and put this into my calculator and get a decimal approximation for it. There's my decimal approximation. Notice I took it out to 6 decimal places just to make sure I had enough. Now I can combine these two terms. Remember that there's actually a 1 in front of this h, so I can just subtract those two values. That gives me h times this value. Now all I have to do to solve this is divide both sides by this value. On this side I'm going to put all of this in my calculator in one step, and that'll give me the answer for h. When I do that, I get 45.092888 for h. Then I want to look at how many significant digits I have. I had 3 significant digits here, 3 here, and actually this one was 2. Even though there's a 0 here, there's nothing that said we were rounding to the nearest 10 feet. We can assume this was rounding to the nearest foot. That means 2 significant digits, which would mean rounding this to the ones place, which would be 45. So the answer to my question for the height of the tree would be 45, and these units were all in feet, so this would be 45 feet.